Thanks for having me here. It's neat to be here. It's a little different audience for me. Often I'm with other scientists or wildlife managers, restoration practitioners in the agencies. But, increasingly as we think about our California ecosystems and how they're going to adapt through time, through climate change, and how we're going to kind of give them the ability to succeed and thrive through the future, I find myself interacting, and I think a lot of people do, looking more at the developed landscapes, the cultural landscapes, as a key part of that story, that vision, and seeing so much potential actually in the developed landscape, which hasn't really been looked at as an ecosystem very much, and what its potential is. We've sort of dealt with it very haphazardly and in a hodgepodge, Rube Goldberg contraption kind of way. So I find myself interacting more with landscape architects and being really interested in that, and engineers, and trying to figure out how we can bring some of that more dynamic ecological processes perspective into the design world, that schism that Peter pointed out. How can design actually embrace those processes and allow systems and processes to happen? That's one reason it's nice to be here. And second is just the Presidio is such an amazing example of all of that actually being applied in a really complex urban setting. So the work of Michael and Craig Middleton is really exciting and inspiring, great example, I think. I guess I'm going to be talking about somewhat of a California perspective, but I do see it in other parts of the country. And it's, that we still have a lot to learn from the natural systems, even in our developed areas. And so I think that we might tend to want to make that schism really, really stark, but as we know, the species and the processes continue, and it's a real spectrum. So I'll show just a few examples of that and give you a little bit of perspective of how we're approaching this culture-nature divide challenge. In brief, through several centuries of impacts, as we know, we've undermined the natural systems that support both wildlife and people ourselves. We find ourselves looking to some of the natural examples of how systems work to figure out how we're going to improve our resilience to climate change. Here's an example of a marsh around the edge of the bay, and if you can see, I can't see from this angle, the sort of ghost remnant of that still there today. At the same time, we need to start adapting to climate change. So we have this sort of double whammy in ecosystem science, that we have highly modified systems, fragmented systems, and yet they're going to be facing climate change. But then we also have the urban and developed landscape facing climate change, and that is having an interesting effect that I don't want to say there's anything positive about climate change, but ironically, it's going to cause our rivers to be more flood prone in California. We're going to have less snowpack and more bigger rainstorms, more intense events. We're going to have to give floodplains back. The flood control agencies are widely preparing for larger floodplains because of climate change. Similarly, the bay is going to get bigger. We've been making it smaller for the past 150 years. It's going to get bigger again. There's really no way around that. A lot of the areas that have been filled will actually become bay again, likely, in the next century. So these trajectories actually are not just one way. And to some extent, all the energy we're putting into the environment through carbon and greenhouse effect is causing nature to come back in some pretty powerful ways, which I don't mean to put a bow and tie on it, but it is making a very complex setting where in California, which has a really a dynamic landscape anyways, of sort of drought and deluge annually and interannually, it's going to kind of make that system more like that. And in fact, so we find ourselves tending towards more xeriscapes and more native plants that are better adapted to probably where we're heading than a lot of the things we've been planting, which are largely based on East Coast and Midwest, things that we were more familiar with and brought here. So interesting trends. So for the next 2 decades, the other point I wanted to make, though, is that our infrastructure is also aging. So, for example, flood control infrastructure in these cities around the edge of the bay or much of California, a lot of it was built in the 50s. There were some big storms, and so we built a lot of big flood control channels. A lot of those are coming to the end of their lifespan, and so we're going to have to redo those. And people don't want the same flood control channel. Not in the LA River, not in Santa Clara Valley, not in Napa. not in Contra Costa County. They don't really want another engineered flood control channel, especially if they're going to have to pay for it this time, because the feds aren't going to help much. So if you have to pass a local proposition to get these systems funded, people want fishes and birds and nice trails along the creek now. So we're going to have to spend a tremendous amount of money to update all our infrastructure, and that's a huge opportunity to change our vision of the city and reintroduce natural processes. And that might actually help us with some of our hazard management, our water supply challenges, as I'll talk about. Here's an example in Santa Clara Valley, just to the south, where live oaks are planted on the median here, a highly developed landscape. And we did a study there about what the natural vegetation used to be and how it's changed, and we discovered this. And so we asked the city forestry folks, gosh, did you realize you're restoring native oaks in a place where they used to be? They said, no, we just planted them because they're the toughest tree for that really difficult environment where it's so hot and so dry. And those are the species that we thought would do really well, and they're doing well. We only had to water them for 1 year. So ironically, and maybe this is a California thing, we have such an extreme environment, a lot of our native vegetation is actually more adapted than some of the things we've been trying to plant for years. So I think we're finding with many of our partners that we can actually rebuild ecosystem resilience and integrate these processes into our landscapes and neighborhoods. How do we do this? A lot of the work everybody's doing, but one of the aspects I think is important is understanding these, and there's a lot of people have been talking about this, understanding our systems in a very deep way, engaging with them, understanding the soils, understanding the trajectories, understanding the potential. My experience is that we often assume not that much is possible and sort of short sell what's possible because we don't actually see the future potential. And so often we are kind of constrained by what we just see in the present day. And that's such small remnants and such a small fraction of the palette. And much of that palette can be enlivened by looking at how these systems in California used to work. And California is so diverse, even the Bay Area is so diverse geologically and climatically that there's a lot to draw from in that palette. It might not be exactly what was there in that exact spot. We might draw from Southern California, but we have a lot of systems that we can learn from. So this work we're doing at what we call the Center for Resilient Landscapes, which is bringing together communities and different partners and a lot of data and science and tools to envision what's possible in the future. And so just looking at this map of the Bay, some of the places we're working is sort of re-envisioning Silicon Valley as what could a resilient Silicon Valley look like. That's work with Google, a lot of the environmental NGOs and agencies in the Delta, developing visions of sort of hybrid landscapes that integrate natural processes with flood protection. You can imagine that's you may hear in the newspapers, even nationally, the challenges there between water supply and endangered species. But we're developing visions of how you can kind of integrate those processes. And then around the edge of the bay, where we've lost so many wetlands, but are in the process of restoring huge amounts of wetlands, and now thinking about adaptation to sea level rise. And the interesting projections that most of the area that we reclaimed over the past century is threatened to become part of the bay again. So that's going to cause us to have to redesign our shoreline dramatically. And we have an opportunity to either use marshes and beaches and do some of the things that New York City is doing now after Sandy, or just build giant walls everywhere, which we probably don't even have enough dirt and concrete to do that, or money. So really interesting times. And of course, those decisions, if we're going to use the softer approaches, we have to start sooner. So, and if we just wait for a disaster, we'll probably end up with a lot of big engineering, which a lot of the big engineering firms are really excited about. So there are big drivers at work. So I'm housed at the San Francisco Estuary Institute, which is a nonprofit, and we also administer a joint powers authority for the state. So we're kind of unusual hybrid organization set up to bring science, cutting-edge science, into the actual realm of practitioners. So working a lot with EPA, with the state agencies, and then down to the cities and counties and flood control agencies and park districts and all of those. So kind of integrating through government, but trying to have a bigger geographic and temporal perspective, because everybody, just by the definition of their job, is generally having to focus at a very small site. So trying to provide that broader perspective. And it's a really neat opportunity because I get to actually test things out and really work with practitioners and develop policies and programs and projects. I'm going to just give 3 examples that I think are intriguing from the Santa Clara Valley. Here's looking at as a system. This might have been a little unfair. I put the map upside down here. So I know that's like a cardinal rule. So let's look at this landscape, which is a heavily urbanized landscape by any of those definitions of impervious or people per square area, and you can just see how gray it looks right here. So the watersheds come out of hills that still have redwoods and comes across alluvial fans that were covered with valley oaks historically into the moist lowland areas, clay-rich soils, and into the bay marshlands. That's sort of the natural gradient there. And interestingly, despite all the development, there's still a lot of threads of the native ecosystem running through this landscape. These areas, which have been converted to salt ponds and have very little of the native tidal marsh, are still really important for native and endangered marsh species, and also all these migratory waterfowl and shorebirds who use the salt ponds. Steelhead still come up some of these streams, salmon, amazingly, despite everything. Not because of any particular efforts of ours, just because they're so tough and they try streams and keep coming up them. There are many native songbirds that are passing through here every year looking for habitat, trying to find enough food to make it to the next stop. And it's not easy, but they do come back every year, as do the steelhead. And you could go on and on with the pollinators and butterflies and bees and insects. So there's a whole native flora coexisting with a lot of invasive species too, but to some extent holding its own. And that's without much effort on our part. The streams kind of connect the whole system. So one of the frameworks I thought I'd toss out that I think is useful to think about, and it was referred to earlier by Peter, is the concept of novel ecosystems. And this is a paper by Hobbs, who's one of our technical advisors, advancing this idea. And the thing that I think is interesting is everybody focuses on the idea of novel ecosystems, which are sort of unprecedented. But in my experience, most things are actually hybrid ecosystems. They have some components of natural or native or long-term functions and some things that are new. It's a combination. And so you may have a landscape that has components of all 3 too. Things that are operating pretty much how they've operated for hundreds or thousands of years. Places that are completely new and bizarre, like the sidewalk cracks. And then a lot of stuff in the middle. And this was, I thought, kind of a key point of this paper, but people have tended to focus on the novel. In most of these areas, you can reestablish or work with natural functions or native functions or ecosystem functions in some aspects. Not necessarily all of the functions, but significant ones. So that's sort of a little background. Now I'm just going to give 3 examples I think are kind of fun. One is looking at those salt ponds, such a dominant feature in our landscape, and a really novel landscape, arguably. They're pretty bizarre. It's like the number one question I get from people. You fly into SFO or Oakland Airport, you see these big expanses of solid pink or green because of the different microorganisms thriving in the ponds, depending on the salinity. And they have also become really important bird habitat for shorebirds in particular, including the endangered snowy plover. So a really interesting situation where you have endangered native species depending on this highly managed, altered landscape. There's that example of what was there. These are historical maps from the 1850s showing the complex tidal network, tidal channel system in the marsh that was there. Now, one of the issues with the salt ponds is that we've been really trying hard to preserve them while restoring tidal marsh in some places because they're so important for shorebirds. But as we deal with sea level rise and start making plans to anticipate the next 50 and 100 years, we realize these are not going to be very resilient or sustainable systems because they're established by earthen berms and that they don't have the ability to move upward vertically as sea level rises, which marshes, natural tidal marshes, actually do have that potential because they grow and they attract sediment. So these systems are cultural constructions that don't really have much longevity to them. And so, people say nature bats last. And in many cases, it's true that things we create don't really have that resilience. So interestingly, one of the things that we've discovered from our research is that there were natural salt ponds in the tidal marsh setting. And those were actually the origin of the whole idea to make salt ponds. Those have the potential to be resilient and supported by natural processes and adapt to sea level rise. So now we're starting to think we want to shift some of these systems to the more natural salt pond. And actually those form by themselves. Once you start looking, you realize nature doesn't go away. These sort of processes are still present in reforming these kinds of features at the edge of the bay. This is a completely new tidal marsh that formed by accident over the last century, outside of where ones had been filled before. So this becomes something that we wouldn't have even noticed if we didn't have a deep understanding of history and how these systems operate and how they can operate in the future. Second example about creeks. One of the discoveries that we had early on was that many of the creeks in the Bay Area, and if not most, and throughout California, didn't actually connect all the way to the bay or the coast. They spread out on their alluvial fans. They didn't really have enough power. Because of our climate in our erosive soils, they would fill up, sort of plug themselves up partway through. They're more like almost like washes, right? But they were creeks, spread out and recharge the aquifer as a result, spreading their waters out and making this real resilience to the system, recharging the groundwater, which would then return lower down in the watershed and gave this buffer or kind of resilience to the system. We have a 6-month drought every year, and then we often have multi-year droughts. So this was a way that water was sort of naturally captured and stored which effectively smoothed out the variations. Of course, what we did to allow agriculture and urbanization is we connected all those creeks up. And really, it was very effective. It really controlled flooding. But now we realize, gosh, all the extensions of channels that we did, all the ditching to drain the valley, was on top of all of the great unconfined aquifer soils, areas that naturally recharge the aquifer. So as we're looking now to get more water locally and being less able to depend on distant supplies and snowpack, we realize, whoops, maybe it would have been, now we realize we lost something there that we value in a time of less plentiful water. So we're not going to allow the creeks to reflood. That would be pretty difficult. Hundreds of thousands of people live there, but we can emulate those same processes through low impact development, swales, slowing water, and actually causing the same process to happen at a local scale and increase the amount of water we can actually capture locally. LA is planning this in a really big way and thinking about how much by doing this, they might even be able to get 50% of their water. Now my third and last example, re-oaking the valleys, which is an interesting counterpoint to some of the earlier conversations about maybe this is a California thing with our extreme environment, but some of the native species are actually more adapted than a lot of the East Coast things we've been trying to plant in our urban areas. So we have tons of trees we plant in the urban areas, of course, and it's not necessarily because they're the best option. It's often, I think, just what's cheapest or quickest or most expedient. And many of them are based on desire for fall leaf color. So we have a lot of temperate deciduous trees. These areas, many of our valleys we've discovered were covered by oaks, but in a scattered kind of setting, a savanna setting, a very appealing kind of pattern to early settlers. So these are live oaks and valley oaks in the Palo Alto area. Towns and settlements were largely built into those groves because these were the best spots because you had shade and just the aesthetics of it. So these were some of the most valued places to live, were in the oak savannas. Morgan Hill, just to the south, was situated in a beautiful grove of oaks. And the reason that they were removed was not really because of residential development, but really particularly because of orchards. They conflicted with the massive expansion of orchards and vineyards in the late 19th century. And so we pretty much clear-cut them. They also weren't good for wood. They weren't clear-cut for their lumber. They're bad wood trees. So we lost them because of the agricultural period. But then, ironically, most of those areas aren't agricultural anymore. Silicon Valley is not agricultural at all. And many of these valleys throughout California that were orchards are now suburbs or urban areas where we actually want shade trees. So ironically, now conditions are actually probably relatively favorable for oaks and other native trees. And as I mentioned in Morgan Hill, these trees actually do really well in these tough settings. Here's an example in Silicon Valley, even more in the Mountain View area, of spontaneously appearing oak trees who've just found their way. Acorns were planted probably by scrub jays. And this is actually in soils that are substantially fill soils on top of native clay soils. So they're actually probably doing better than a lot of other non-native vegetation in this case. So there's an interesting observation that you can support a lot of native species who follow the oaks. The oaks are a real keystone ecology component of our landscapes. And they support a whole variety of oak-associated birds and bats and insects. So if we bring back the oaks, we may be able to bring back a lot of the ecosystem and have all these other benefits in terms of carbon storage, slowing down urban runoff, shade, heat island effect, et cetera, et cetera. Here's another spontaneous oak that popped up. It's pretty young, so I think it's subsequent to this development. And it's a valley oak, which is a declining oak, and yet it has appeared here in the heart of San Jose. Just to show you ecological infrastructure, this is an office chair underneath it right here. And it's actually chained to the oak tree with a big, heavy chain because the guys who run this kind of sketchy auto lot, they actually sit here under the tree and do their office business and sell cars out of there. So that's spontaneous ecological infrastructure of native species. Now, if there were 3 other valley oaks within 60 meters, they would be genetically communicating and actually able to produce acorns that might be able to adapt to future conditions. As it is, there's just that one, probably randomly planted by a scrub jay. But if there were sufficient trees, and these species go far south, so they have a broad climatic envelope, very drought tolerant. So you can see the potential by looking at these spots. Here's an oak tree we planted in our neighborhood in the traffic circle, which has grown tremendously. So it'll survive if it gets hit by a car. The car won't. So the idea of re-oaking, which has been gaining a lot of interest throughout the region, where we had this scattered pattern of oaks. There was a tremendous decline for agriculture. And without attention, there'll be just continued attrition, but not for any fundamental scientific or technical reason, but simply because us not recognizing the opportunity or utilizing that potential or choosing to. So there's no reason that we couldn't actually bring back a significant amount of oak trees in this particular example and gain a lot of the other ecosystem services associated with them. So I know I'm pretty much out of time, so I'll stop here. I love this image of the Bay Bridge. Here's the railroad that went out to the ferry to cross the bay. And this is in 1933, I think it was. And then here's the new Bay Bridge being constructed. And of course, that is now being deconstructed, and the new Bay Bridge is right over here. It just reminds you how our landscapes are constantly changing and turning over, even the things that seem so fixed and fundamental at the time. We have the opportunity and responsibility to shape what that next generation is. So thank you very much.